Dear students, this is Vijayanand working as Associate Professor in RMK Engineering College in the Department of Electronic and Instrumentation Engineering. I have taken digital signal processing subject many times. Today we are going to see Unit 5. If you see the syllabus, Introduction, Architecture, Features, Addressing Formats, Functional Modes, Introduction to the Commercial Processor. Let us see one by one. First, introduction. DSP processor or microprocessor designed for the efficient and mathematical manipulation of digital signals. There are two types of DSP processor. One is general purpose DSP processor and second one is special purpose DSP processor. General purpose digital signal processors are basically high speed microprocessor with architecture and instruction set optimized for DSP operation. Special purpose digital signal processor consists of hardware designed for specific DSP algorithm such as FFT, PCM and filtering process. These are the different Texas Instrument DSP processor family that are available in the market. If you see C2000 series, it is used for motor control, storage and digital control system. C5000 series used for wireless phones, internet audio players, digital still cameras, modems, telephone and VoIP process. C6000 series used for multi-channel and multifunction applications, communication infrastructures, wireless base stations, DSL, imaging and multimedia service and video applications. DSP applications like MPEG audio, portable audio, digital cameras, cellular phones, wearable medical applications, storage products, industrial control, networking and military applications. How to select a digital signal processor? First point is architecture features, size of on-chip memory, special instructions and input-output capabilities. Execution speed, clock speed, number of operations performed in one cycle, that is measured as MIPS, million instruction per second. Type of arithmetic, fixed point, low cost and high volume application, whereas floating point it is expensive, that is used for higher applications. Word length, number of bit size like 16, 24, 32, etc. Longer word length, lesser error. Types of architecture. Von Neumann architecture. In 1946, John von Neumann developed a first computer architecture that allowed the computer to be programmed by codes residing in memory. Von Neumann architecture, the CPU can be either reading an instruction or writing data from or to memory. Both cannot occur at the same time, since the instruction and data use the same signal pathways and memory. The von Neumann architecture consists of three buses: data bus, address bus and control bus. Data bus are used for transport the data between CPU and its peripherals. It is bidirectional. The CPU can read or write data in the peripherals. The address bus uses the address bus to indicate which peripherals it wants to access and within peripherals with specific registers. The bus carries signals that are used to manage and synchronize the exchange between the CPU and its peripherals, as well as the indicates if the CPU wants to read or write the peripherals. Harvard architecture. Harvard architecture physically separates memories for their instruction and the data, requiring a dedicated bus for each of them. Instruction and operands can therefore be fetched simultaneously. Most DSP processors use a modified Harvard architecture with 2 or 3 memory buses, allowing access to the filter coefficient and input signals in the same cycle. Since it possesses 2 independent bus systems, the Harvard architecture is capable of simultaneous reading an instruction code and reading or writing a memory or peripherals as part of the execution of the previous instruction. Modified Harvard architecture use DSP multi-port memory that has separate bus system for programming memory and data memory and input-output peripherals. The third one is VLIW architecture, very long instruction word architecture. It is essentially a concatenation of several short instructions and require multiple execution units running in parallel to carry out the instruction in a single cycle. The very long instruction word processor consists of architecture that reads a relatively large group of instructions and executes them at the same time. The VLIW processor combines many simple instructions into a single long instruction word that uses different registers. The advantages are increased performance, better compiler targets, potentially easily to program, potentially scalable, can add more execution units for fast processing. The disadvantages are a new kind of programmer or compiler complexity. Program must keep track of instruction scheduling, increased memory use, high power consumption and misleading million instruction per second ratings. MAC, a multiply accumulate unit. It can multiply a 16 into a 16 data. Pipeline. The most of the early microprocessor executes instruction entirely sequentially. After the execution of first instruction, the next one starts. The problem with this that it is extremely inefficient since the second instruction has to wait until all the steps of first instructions are completed. To improve the efficiency, advanced microprocessor and digital signal processor use an approach called pipelining, in which a different phase of operation and executions of instructions are carried out in parallel. It has fetch, the next instruction is fetched from the address stored in the program counter. Decode, instructions in the register is decoded and increment the program counter. Memory read, reads the data from the data bus and also writes the data to the data bus. Executes the instruction currently in the instruction register and also completes the write process. This is a pipeline example for 4 stages. You can see instruction 1, in first cycle the data is fetched. If you see the second cycle, the first instruction is decoded. Simultaneously, the second instruction is fetched and kept ready.